Imagine pointing our eyes to the sky and knowing that out there, relatively close in cosmic terms, there's a star with a planet that could support life. Now imagine how frustrating it is to know that, even though it's the closest star after the Sun, Proxima Centauri remains completely out of our reach. In this video, we'll explore why reaching this stellar neighbor is one of humanity's greatest challenges, and why, even so, scientists are determined to get there. The interest in Proxima Centauri is no coincidence. Observations made with the most powerful telescopes in the world have revealed that this star hosts at least one potentially habitable exoplanet, Proxima b. It may have the necessary conditions for life to exist, or even serve as a future destination for human colonization. This turns the star into more than just a bright dot in the sky. It becomes a strategic objective for the future of our species. But the question remains, with everything we know and have developed so far, is it possible to get there? The short answer is impossible, at least not with today's technology. And unfortunately, the long answer is even more frustrating. So far, humanity hasn't even managed to send a human beyond the moon, which is about 384,000 kilometers from Earth. And despite the incredible achievements with probes like Voyager 1, the most distant object we've ever launched, we still haven't truly left the neighborhood of our solar system. Voyager 1, launched in 1977, is traveling at 17 kilometers per second. That's about 540 million kilometers per year. Impressive? No doubt. But at that pace, it would take around 76,000 years to reach Proxima Centauri. And that's if it were headed in that direction, which it isn't. To make a trip to this star possible within a human lifetime, we would need speeds completely beyond our current capabilities. The bare minimum would be around 10,000 kilometers per second. That way, we'd reach Proxima Centauri in 130 years. Still a long time, considering most people don't live a full century. If we could reach 25,000 kilometers per second, the time would drop to 50 years, which sounds more doable. But we are still very, very far from that goal. This means we must completely abandon the idea of using conventional chemical propulsion, the traditional rockets we use to get to space. To reach just 1% of the speed of light with this kind of propulsion, we would need something utterly absurd, more than 1,000 trillion kilograms of fuel for every kilogram of the spacecraft. That would mean a spacecraft with 100 times the mass of Earth. Completely unfeasible. That's why the only way forward is to invest in new forms of propulsion. And in this scenario, we have to make a few concessions. For example, we must forget about sending astronauts. A crewed mission would consume much more resources, energy, and time. An automated probe mission is far cheaper, more practical, and technologically achievable. We can also consider something simpler. Instead of trying to enter orbit around Proxima Centauri or land on one of its planets, we could just fly by the system and collect data during the pass. That alone would be a gigantic step forward and would save a lot of energy. But after all, what propulsion technologies could take us there? One of the first options that comes to mind when we talk about new forms of propulsion is the ion or plasma engine, which has already been used in several missions within the solar system. They offer continuous thrust over long periods and are much more efficient than chemical engines. We also have nuclear thermal engines, which use reactors to heat gases and expel them with force. But while interesting, these technologies would still take more than 40,000 years to reach Proxima Centauri. Clearly, that's not enough. A more promising development is the VASIMR engine, which stands for Variable Specific Impulse Magnetoplasma Rocket, developed by the Astra Rocket Company, led by Costa Rican former astronaut Franklin Chang Diaz. VASIMR is a plasma engine with the potential for faster travel within the solar system. For example, it could reduce a mission to Mars from 18 months to just 39 days. Pretty impressive. But even with all that performance, it would still take around 2,200 years to reach Proxima Centauri. Better, yes, but still way, way beyond a human lifetime. Another technology that sounds like science fiction, but has actually been studied, is nuclear pulse propulsion, better known as Project Orion. This concept uses nuclear bomb explosions behind the spacecraft to propel it forward. A gigantic plate, mounted on shock absorbers, would absorb the impact from the explosions and transfer the energy to the ship. The idea was partially tested in the 1960s, and theoretically, with fusion explosions, much more powerful than fission, we could reach much higher speeds. But there's a catch. About 300,000 explosions would be needed to propel the spacecraft, and we're talking about a colossal structure, about 400,000 tons with a plate 100 meters in diameter. Even with all of this, the trip would take around 150 years. That may sound like a lot, but it's actually a somewhat realistic proposal for a generation ship, meaning a spacecraft where several generations of humans would live and die until arrival. Even so, it's a costly, risky project and probably only viable in a more distant future. Another technology on the list of most discussed ideas is the solar sail. Contrary to popular belief, these sails are not pushed by the solar wind, but rather by radiation pressure from sunlight. The Japanese probe has already tested this concept on a small scale. The idea is to use a gigantic sail, similar to a space parachute, to capture this light pressure and gradually accelerate until exiting the solar system. However, for this strategy to work, the sail would need to be deployed close to the sun, where radiation is most intense. On top of that, it would have to be extremely lightweight, enormous, and resistant to absurdly high temperatures, reaching thousands of degrees Celsius. Even with all that, the trip would still take between 1,000 and 2,000 years. In other words, a solar sail alone doesn't solve the problem, but it could be combined with other technologies to shorten the travel time. There are even projects that combine solar sails with nuclear explosions, like the Medusa concept from the 1990s. In that model, controlled explosions would generate radiation waves that a super-resistant sail could capture, pushing the spacecraft forward with greater force. It would even be possible to use the same spacecraft to visit Proxima Centauri, and then continue on to Alpha Centauri A or B. But perhaps the boldest version of sails is the laser sail, also known as a photonic sail. Instead of using sunlight, this system would be powered by extremely powerful lasers positioned in Earth's orbit. These lasers would fire continuous beams at the sail, pushing the spacecraft toward the closest star. If we had a laser array with 25 gigawatts of power, we could send a small 100-kilogram spacecraft to Alpha Centauri in just 40 years. That's not a long time compared to the 45-plus years Voyager has spent traveling, and it hasn't even come close to leaving the solar system. But of course, everything comes with a price. The lasers would need to operate non-stop for 4 decades, and the spacecraft couldn't be too heavy. Otherwise, the travel time would increase dramatically. This brings us to one of the most realistic and exciting projects so far, Project Starshot. Project Starshot is without a doubt one of the most ambitious proposals ever conceived for reaching the stars. It was created by the Breakthrough Initiatives program and, surprisingly, it's not just a theoretical exercise, it's a real plan, with scientists and engineers actively working to make it happen. The idea is simple in theory, but revolutionary in practice. To send a fleet of microsatellites, called starships, toward Proxima Centauri, propelled by photonic sails and powerful laser beams. These spacecraft would be incredibly light, only a few centimeters in size and weighing just a few grams. A mothership would carry thousands of them into Earth's orbit, where they would be released into space. From there, massive lasers positioned on Earth or in strategic points in space would fire concentrated beams of light at the sails of the probes, accelerating them to speeds of up to 20% the speed of light. That's 60,000 kilometers per second, or 215 million kilometers per hour. At that astonishing speed, each probe could reach the Proxima Centauri system in just 20 to 30 years. And since the distance to the star is just over 4 light years, it would take another 4 years to receive the signal back on Earth after arrival. That means that still within this century, we could witness the first successful mission of a human-made spacecraft, even if robotic, to another star. While passing through the system, the probes could fly by Proxima b, the most promising planet in that star system. Positioned at about 1 astronomical unit away, the same average distance between the Earth and the Sun, the onboard cameras could capture high-resolution images and collect valuable data about its atmosphere, composition, and potential signs of habitability. Since these probes would be extremely small and fragile, The risk of collision with interstellar dust particles would be high, but the Starshot project compensates for this risk with numbers. By launching thousands of units, even if many don't survive the journey, some would definitely complete the mission. Each one would be equipped with compact laser communication systems capable of sending data back to our planet. What's most impressive is that this project, which sounds like something out of a science fiction movie, could become reality within the next 2 decades as long as it receives the necessary funding. With proper investment, we might see this mission executed within our generation and, who knows, the first real image of a planet in another star system. Even if we don't find worlds like Pandora from the movie Avatar, or any form of alien life, a mission to Proxima Centauri would have immeasurable scientific value. It would allow us to closely study planetary formation processes in another star system, compare them with our own, and better understand how the Milky Way itself works. As Carl Sagan once said, "When we're ready to visit other stars, we will no longer be the same. The human species will need to have matured. Only a wise and resourceful civilization will be capable of facing and overcoming the immense void between the stars. If we want to survive in the long term, thrive, and leave a lasting mark on the universe, we need to look beyond our small blue planet." Going to the stars isn't just about scientific curiosity. It's an existential necessity. And Proxima Centauri, with its promising world in orbit, could be the first step in that epic journey. The technology isn't fully ready yet, but the desire, the drive, and the courage to try, those are already part of who we are. The question now is, will we have the determination to turn this dream into reality?